I want to thank everyone for joining us today. I'm going to give just a real short summary of what we reviewed today. Just quickly, wanted to go through the presentation and thank our sponsors and our co-hosts for today. We could not put an event like this on without them, so thank you for that. We covered the family of open source cores that we're working on in the Open Hardware Group, the Core 5 cores. So go and look for more detail on that if you want to see some of that detail, specifically the CVE4 embedded class 4-stage core and the CVA6 and our RB64 GC class core. Very popular cores written in System Verilog from the team at ETH that are now part of Open Hardware Group. We had the Quick Logic guys join us and talk about the Core 5 MCU SoC that we'll be taping out in GlobalFoundries 22FDX in Q1 is the plan, and that's based on an Arnold test chip that was developed at ETH a couple of years ago. So it's a cool program. We'll produce between 1,000 and 10,000 boards with this chip on it to get into developers' hands. And if you want to participate in how this takes shape, the project proposal's going before our technical working group probably later this month. And you can join the technical working group and the task groups that are driving this project to help drive the shape, how this takes shape. Then on the tool side, we had the team from Eclipse, Frederick and Alexander, talk about some of the work in the Eclipse toolchain, and in particular, the Core 5 IDE work that's going on there in terms of how that's being developed and how to participate in that. And then in the afternoon, we started a series of hands-on sessions. Hopefully, those of you that were playing with your Nexus board got the help that you needed, and you were able to get some satisfaction out of getting some stuff up and running and getting some debug sessions going. And we thank our sponsors from Digilent for helping us with these boards. And the Core 5 MCU work that we're doing that will eventually be in the 22 FDX node will first be in this FPGA environment. So that work is proceeding nicely. We also had a talk from the Embicosm guys on the GCC toolchain work, and in particular, the hardware loop instructions that are part of the pulp extensions developed at ETH that will be supported and upstreamed into mainline GCC over time. I think Mary showed an example of how mCopy's improved with hardware loop turned on. So there's some interesting advantages there. And we thank the Embicosm team for their support. And then we had the team at Ashling show us what the Eclipse IDE environment looks like within their risk-free IDE environment. And that is the basis for what will go into the Core 5 IDE environment. And as I said earlier, talking about Frederick and Sebastian's talk, that's an active development project that's happening within our software task group, as are the GCC toolchain improvements. So you can participate in that activity if you want to see how and influence how this takes shape inside the software task group. And then after the hands-on sessions ended, we had two talks. The guys from BlueSpec showed us how this really cool Explorer platform to evaluate and compare and contrast different open source implementations. The mileage may vary on all of these, as always. Not all of the implementations are the same, even though they might implement the same extensions. In some cases, there was support for atomics, for instance. In some cases, there wasn't. But the point is, you can in real life, applications that you might want to run, you can compare and contrast how well these cores do. So that was very interesting. And then finally, we had Sebastian take us through his work, which is quite interesting, and in terms of the need. And this really just illustrates fundamentally why RISC-V, in my opinion, is being adopted in the fashion that it is. It really illustrates the need for purpose-built computing at a performance and power budget that you just can't get with a general purpose CPU and a PC kind of structure. You need to have the data acquisition point very, very close to the compute environment. You need to have tailored compute environment with accelerators that are structured specifically for the shape of your data set. And you don't want to be wasting, let alone time, but power envelope to send this data set somewhere else. Some kind of, at the thing in the Internet of Things, but at the thing edge of the network, doing the computing locally with a purpose-built accelerator, and the flexibility of the RISC-V ISA and adding custom instructions and so on makes that actually achievable. So there'll be a lot more research in that. So with that, thank you again to our sponsors. And next year, we really hope we're doing this all together in a room with a couple of hundred people for the hands-on sessions, as opposed to trying to do this online. So at the risk of jinxing anything, mark the 14th and 15th of September 2021 in your calendars, and plan on coming to Canada's nation's capital and enjoy the fall colors and the leaves, and participate in Open Source Developer Forum 2021 next year. So with that, thanks for participating, and we'll see you soon online. Thanks very much.